Okay, let's unpack this. Have you ever stopped to think about what a law of nature actually is? Like, is it some kind of cosmic rule book the universe absolutely must follow? Or is it maybe more like a really brilliant summary of what we just see happening, almost like a cosmic weather report?
That's a fantastic question. And you know what's so compelling here is that it's not just some dusty philosophical debate.
Right.
It genuinely shapes how we do science, how we think about the universe's limits, even how we frame scientific discovery itself.
So today we're diving into excerpts from this really fascinating article called Laws of Nature, Governance or Description, to tackle this exact question. And our mission really is to pull out the key insights for you, give you a kind of shortcut to understanding this pretty deep discussion. So jumping right in, the article highlights the central tension. Are these laws of nature fundamental, like governing facts? Or are they just really good descriptions, summaries of patterns we observe? The article gives this great analogy to clarify. Think about it like this. Are laws more like traffic laws? Things that actively govern behavior, make cars stop and go. Or are they more like a weather report, which, well, it just describes the weather patterns. It doesn't cause the rain.
Exactly. And the article breaks down two key aspects of laws that are really central here. First, there's the unifying aspect, how laws manage to bring all sorts of different natural events under one single idea.
Like Newton's laws, right? Apples falling, planets orbiting, same rules.
Precisely. But then there's the second aspect, the constraining or maybe governing aspect, the idea that laws actually dictate or limit what nature can do.
Okay.
And the article points out two opposing views. There's Barry, who really emphasizes unification. He's pretty skeptical about the constraining part, though. For him, laws unify beautifully, but they don't make nature follow them. He definitely leans towards that weather report idea.
Okay, so Barry's more in the description is enough camp?
Right. But then you have Eddie's view. He argues that no, you need both, unification and constraint. For Eddie, that constraining bit is crucial because that's what gives the unifying framework its explanatory power. It explains why.
Ah, I see. So it's not just summarizing what happens, but explaining why it has to happen that way.
Exactly. He's much closer to the traffic laws view. The laws actively direct things.
So where did this whole laws of nature idea even come from? The article mentions it's a bit fuzzy historically, right?
Yeah, there isn't like one single ancient source we can point to for the exact modern concept. But the current understanding often gets traced back to one particular thinker,
And that would be.
René Descartes. He had this vision, you see, of a few core mathematical principles, and these principles, for him, described how God moved matter around in the universe.
So God was the ultimate governor in his view.
Crucially, yes. For Descartes, these weren't just abstract facts. They were descriptions of God's actions, God's governance. And he figured they had to be mathematical because, well, God, like Descartes himself, was a mathematician. Order through numbers.
That's fascinating. And who was it that really took that mathematical vision and ran with it, unifying huge chunks of nature?
Well, that, of course, leads us straight to Isaac Newton. His work was monumental in actually realizing much of that unifying vision, showing how just a few laws could cover so much ground. Though it's interesting, the article points out this historical gap. Despite how central laws of nature are to science, their actual history hasn't been explored nearly as much as, say, the history of probability.
That is strange, isn't it? It's like we just take them for granted.
Kind of, yeah.
Okay, but let's circle back to a challenge for that description-only view, the weather report idea. If laws are just descriptions, then why do they seem so incredibly solid? Like, why do they appear to have absolutely zero exceptions? That perfect track record feels like more than just a summary.
That's a really sharp point, and it ties directly into this deep-seated belief in science, something people like Einstein held very strongly. The belief that nature, at its core, is unified, that there's an underlying order.
Okay.
And this drive for unity, this aspiration, kind of suggests there must be a deeper reason why we don't see exceptions. It implies something more fundamental than just a good description of past events.
But the article adds a dose of reality here, right?
Yep.
Even our best theories, our biggest laws like general relativity for the huge scales and quantum mechanics for the tiny, they don't actually fit together yet. They aren't unified.
Exactly. It reminds us that a truly unified theory, that single grand description, is still something scientists are working towards. It's an aspiration, like you said, not a finished product.
Okay, this next part gets a bit more technical, but sounds really cool. The article brings up algorithmic information theory and this idea of the universe being compressible. What exactly does compressible mean here? Does it relate to, like, zipping a file on a computer?
Yeah, that's actually not a bad analogy. Compressible basically asks, can all the complex stuff the universe does, can it be boiled down to surprisingly short, elegant rules? Think about Newton again. He took mountains of observations about motion and gravity and compressed them into just a few equations. That suggests the universe is at least somewhat compressible, and Kolmogorov complexity, which you mentioned, is basically a way to measure that. It asks, how short is the shortest possible description, like the shortest computer program needed to generate a certain pattern or outcome?
So low Kolmogorov complexity means highly compressible, easy to describe with short rules.
Precisely. And science historically has been incredibly successful at finding these shorter, more elegant descriptions. It keeps finding ways to compress our understanding of nature.
But it's still an open question, the article suggests, whether everything about the universe is ultimately compressible like that.
Right. Or maybe some complexity is just irreducible. Maybe some things just are complex and you can't boil them down any further. We don't know for sure. And, this whole discussion about compressibility, it naturally leads to an even bigger, maybe deeper question. Is there some kind of super law? A reason why the universe seems to follow these simple, elegant, compressible laws in the first place? Why isn't it just, random chaos?
Right. And we mentioned Descartes earlier. For him, the answer was simple. God. God set it up that way.
Yes, God was his meta law, if you like.
But how does modern science handle that question? Is there a consensus now on why the universe is orderly or compressible?
Well, no. There really isn't a consensus. It's still very much debated. Some scientists and philosophers kind of take compressibility as a given. It's just a fundamental feature of reality, the way things are. No deeper why needed.
Okay, it just is.
But others view it as what philosophers call a contingent fact, meaning it just happens to be true about our universe, but it didn't have to be this way. There's no underlying principle guaranteeing it. So yeah, the question's still wide open.
It's interesting how scientists talk. They often use that governing language, don't they? Like, laws constrain behavior or nature obeys these laws. The article suggests that might just be a habit, right? Left over from that Cartesian picture of God actively governing things.
That's exactly the argument, and it creates this philosophical split we talked about earlier. Barry, the description advocate, would say, yeah, that governing talk is just a conceptual crutch. It's unnecessary baggage, implying an active force that science hasn't actually found.
Just get rid of it.
That's his view. But then Eddie counters, saying, hold on, if you drop that governing language, you might actually lose something crucial. You lose the explanatory power.
How so?
Well, it's the difference between saying, this is what happens, and this is why it has to happen this way. That why, Eddie argues, comes from the constraining aspect, the idea that the laws are directing the outcome.
Okay, let's make this concrete. How does this debate play out with something specific? Like, the article mentions the principle of least action. That's a big one in physics.
Right, a fundamental principle. It basically says that when something happens in nature, like light traveling or an object moving, it follows the path that requires the least action, sort of the most efficient path.
Okay. So how do the two viewpoints interpret that?
Well, one interpretation, leaning towards Eddie's governing view, might say that nature really is actively minimizing action. It's like the law is telling the particle, okay, take this path, it's the easiest one, it's doing something purposeful.
He's making a choice, almost.
In a manner of speaking, yes. But the alternative view, closer to Barry's description camp, says no, that's just a very elegant mathematical way to summarize the path things end up taking. It's like the weather report. Again, it accurately describes the path, maybe even predicts it, but it doesn't cause the path to be chosen.
So it's not just arguing about words. It really cuts to the heart of how we interpret what science discovers.
Yeah.
Are we finding the rules or just the patterns?
Exactly. It's about what we think reality is and what we think our scientific models are actually telling us about it.
Wow. So this deep dive, it really wasn't just about the history of laws, was it? It's fundamentally about how we read them, how we understand our place in the universe described by them. Are they cosmic traffic cops enforcing order? Or are they just incredibly neat summaries of the traffic flow? It changes your perspective.
It really does, and it leaves us with some big questions to ponder, doesn't it? Building on what the article discussed, like, why is the universe so incredibly well described by mathematics anyways? Is that just a coincidence?
Good question.
And is there some kind of meta principle out there ensuring this compressibility, this orderliness, or did we just get lucky with the universe we ended up in? And maybe most critically for science itself, can we really ditch that governing aspect, the idea that laws dictate what happens, without actually losing the power to explain things?
Lots to think about there. Definitely something for you to mull over until our next deep dive into the fascinating world of knowledge.